In this video, we're going to be talking about the second part of section 2.4, and this should go pretty quickly. We're going to be talking about complex numbers some more, but we've done add, we've done subtract, and we've done multiply. So today we're going to do the complex numbers version of division. All right, so to get started, we're going to review a little topic here, again, about rationalizing the denominator. So if you recall, it's considered bad form to have a radical in the denominator of your fraction. So I'm looking here at 2 minus the square root of 5, and I need that to not have that square root of negative 5. So we need to approach this in a way that makes sense. And one way we might approach this, not sure if it's changing, it is. One way to approach this is like, well, I don't want that square root of 5 there, and I seem to remember yesterday in this last video, so do I multiply by the square root of 5 over the square root of 5? Seems like a good approach, but the problem is I'm multiplying the square root of 5 by not one term. I got to do it by both. So it'll clean up this square root of 5, but it's going to be now planted on this 2. And so that's not going to get the job done. What is going to get the job done is multiplying by what we would call the conjugate. So if you remember, the conjugate is, if you have a plus b, the conjugate of a plus b would be a minus b. These are what's known as conjugates of each other. So they're not opposites, right? We didn't change the a to a negative. We just changed the operation in the middle. A plus b becomes a minus b. So what's going to happen here is if I multiply by the conjugate, so I'm going to multiply by 2 plus the square root of 5 over 2 plus the square root of 5. Then in the bottom, what we've set up is a multiplication that is going to give us the difference of two squares, right? We have multiplying conjugates together. So I'll multiply this out once, but I want you to notice that really we can jump ahead to the end. So 2 times 2 is 4, and I get plus 2 root 5, and I get minus 2 root 5, and then I get negative times a positive is a negative. Root 5 times root 5 is root 25, or just 5. The two middle terms cancel out, and now I'm left with 4 minus 5, and I get negative 1 in the denominator. So I multiplied two irrational numbers together, and I ended up getting a nice, good old-fashioned rational number. So multiplying by the conjugate works because these middle terms cancel out, and that's where my radicals are, because when I do radical times the radical, they disappear and become a real number. So that's going to give me an answer, which I guess I'll just slide over here because I took up my space, of 2 plus the square root of 5 over negative 1. Now that looks kind of ugly. I don't feel like leaving it like that. So I think I'll rewrite this one of two ways. I think the best would just be let's call it negative 2 minus root 5. Having it divided by negative 1 is kind of silly. Okay, let's look at part B. To rationalize this one, we can do overkill, or we can plan ahead. So what I'm looking at is I'm doing the 5th root of x cubed. I cannot take the 5th root of x cubed, but you know what I could do is I could take the 5th root of x to the 5th. So if I had a 5th root of x to the 5th down there, I'd be in good shape. So I don't want to give more than I need. Let's just multiply by the 5th root of x squared over the 5th root of x squared. Since they're both the 5th roots, I can put those together, and on top I have the 5th root of x squared times 1 over, and then that becomes the 5th root of x cubed times x squared. Because remember, if they're factors, we can do them separately, and I can split them into that one times that one. Or I can do the reverse. If they're separate, I can bring them together. So then, of course, this just becomes the 5th root of x squared. That's not very good. Let's try that again. The 5th root of x squared over the 5th root of x to the 5th, which is simply x. And no, do not simplify these. Again, this is not just a regular old x. This is a fifth root. So we cannot do anything with those. And then on this one, we are going to have to multiply by the conjugate. I want you to notice that C and A are basically the same question. Okay. This is a radical. It's just not written as a radical. But remember, an I just has a radical in it. Okay. So they're very, very similar. So what I'm going to do is I'm going to multiply by the complex conjugate is what we would call it. But it's still just the conjugate. So I have 2 minus 5i. I'm going to multiply by 2 plus 5i. So I know that the middle stuff's all going to cancel out, so I'm not going to show my work this time, at least not all of it. I know that I'm going to get 2 times 2, which is 4, a negative times a positive, which is a negative. 5 times 5 is 25. I times I is I squared, which is a negative 1. On top, I get 3 times 2 plus 5i. So on the bottom, I'm going to get 4 plus 25. And on the top, I kind of was waiting to distribute this through because if this number was divisible by 3 when I'm done, I could reduce that 3 with this number. But now I can see it's not going to happen. So I might as well just go ahead and call it 6 plus 15i, which means I've got 6 plus 15i over 29. Now, if this question had asked you to please make sure you leave your answer in standard form of an of a complex number, technically I have not done that. To make it in standard form, I would then just need to separate it out. So I'd get 6 29ths, there's my real component, plus 15 29ths, none of which reduces, I. And that would be in standard form. All right, so really all we're going to do today is we're just going to practice that. So you can see 4 questions here. Go ahead and pause the video and give that a try. All right, so here we go. Let's rationalize. So I'm going to multiply by 2 plus 5i over 2 plus 5i, multiplying by the conjugate. On the bottom, I'm going to get 4. Negative times a positive is a negative. 5 times 5 is 25, just like I had a second ago. Is this the same question? It is the exact same question. So we're going to jump ahead. That was a mistake on my part. All right, part B. Multiply by the conjugate. On the bottom, I'm going to get 9 minus 16i squared, or negative 16. This becomes 9 plus 16. 3 times 5 is 15. Minus 20i. Minus 3i. Minus a negative is plus. 4 times 1 is 4. I times I is I squared. So this ends up being minus 4. Now, it's not going to be a big surprise when you hear me say that the biggest mistake you're going to make is just with your negatives. So pay very close attention. A negative times a negative turns to positive, but then I'm also doing I times I, which is I squared, which turns it back to negative. Or show additional steps. 15 minus 4 is 11. So I get 11 minus 23i over, is that right? Looks good. 9 plus 16 is 25. And so let's write it in standard form. 11 25ths is my real component minus 23 25ths I, and there's my imaginary component. All right, let's keep going. All right, on this one, I'm asking you to subtract these fractions, and we should know that we can only subtract fractions if they have the exact same denominator. All right, so I'm looking at this, and I'm noticing probably a little bit of simplification that I can do. So I'm going to rewrite this problem. I'm going to write it as 1 over, I'm going to factor out a 2. And that's going to give me 2 plus I minus, I'm going to factor out a 2 here, and that gives me 1 minus 2I. All right, so now when I need a common denominator, I need all the factors on the bottom for each of them. So what that means is this fraction is going to need, it's already got the 2, it's already got the 2 plus I, it doesn't have the 1 minus 2I. So I need to multiply that one by 1 minus 2I over 1 minus 2I. And if I multiply it by that, then I'll have 3 factors in the denominator. And if I go look at the other one, if I multiply this one by 2 plus I over 2 plus I, then they will all have the same thing in the denominator. And it would look something like this. I'll have 1 minus 2I over 2 times 2 plus I times 1 minus 2I minus this guy. He'll have a 2 plus I on top. On the bottom, he'll have exactly the same as the other one. And the 1 minus 2I. So now I have common denominator, and I can go ahead and subtract them. Be careful, it's a subtract. So I'm going to just kind of show my steps a little bit, maybe to a ridiculous level here. 1 minus 2I minus everything on top, 2 plus I. On the bottom, I have 2 times 2 plus I times 1 minus 2I. And so I'm going to distribute that negative. Again, kind of showing a lot of steps here. It's going to get kind of silly long. I'm tired of red. Let's switch. 1 minus 2I minus 2 minus I. Distribute that negative. And I got to do some work on the bottom eventually. I'm just kind of putting it off. All right, my numerator is going to turn into negative 1 minus 3I. My denominator needs to do some work. I'm going to multiply the two parentheses together, and I'll leave the 2 on the outside for now. 2 times 1 is 2. Negative 4I minus I minus 2I squared, which gives me a 2 times, all right, negative 4I minus I is obviously minus 5I. And this I squared right here is negative 1, so this becomes plus 2. And I have this plus 2, so I end up getting 4 minus 5I. All right, that was a lot of work, and I'm not even done yet because I have now added them together, but I need to rationalize. So I'm going to multiply by the conjugate, top and bottom. So now I'm going to multiply by 4 plus 5I over 4 plus 5I. All right, and I'm just going to move up here, and we'll worry about D in a minute. So on top, I'm just going to write it for now. Negative 1 minus 3I times 4 plus 5i over 2 times, and I'll go ahead and do this because this is the shortcut, right? So everything's going to cancel out for the most part. I'm going to get a 16 minus, but that's going to turn into plus. 5 times 5 is 25. Negative times positive is negative, but the I squared turns it back to positive. So this becomes plus 25. Okay, which means I've got in the top, now I'll go ahead and distribute that, negative 4 minus 5i minus 12i minus 15i squared over 16 plus 25 is going to be 25, 35, 41. 2 times 41 is 82. And in the numerator, what do I got? All right, negative 15i squared is plus 15 and a minus 4. So that's going to be 11 minus 17i over 82. Finally giving me an answer of 1180 seconds minus 17 over 82i. Phew. All right. Hopefully I didn't make a silly mistake in there. Hopefully you see why I made all the choices that I made. All right. Part D, we are going to remember that raised to the negative 1 power really means 1 over 2 minus 3i. And so now I need to multiply by the conjugate to clean that up. And that should be pretty straightforward. Much better than the last question. 2 plus 3i over, let's see, can I do this in my head? 4 minus becomes plus 9. 4 plus 9 is 13. 2 thirteenths plus 3 thirteenths I. All right, one little concept left. Let's scroll down. All right, let's graph each complex number. Now, we're not going to do much with graphing complex numbers. In fact, if you are very artistic and inclined, I would encourage you to look up fractals. Do some Googling on something called a fractal. Fractals are graphing images that come from the complex number plane, and you can make some pretty interesting pictures out of fractals. I don't claim to be an expert on fractals. That's one class I didn't take in college. So I'm not going to pretend like I'm an expert, and we're going to do very, very little with this. So we know what the real number system is. The complex number system looks very similar. So the complex plane consists of kind of like an X and a Y. But this time what we're going to have is this is going to be the real number line. And the vertical is going to be the imaginary. And so when we're going to graph 4 plus 3i, it's kind of like an X and a Y. 4 on the real number system. So we're going to come over to 4. And then 3 on the imaginary puts us up here at that point. So that is the point graphed on the complex plane. That is 4 plus 3i. Okay. That is that point right there. All right, so go ahead and see if you can graph the negative 2 plus I on the number plane, complex plane. And so this time we're going to go 2 on the real, negative 2, and we'll go plus 1. And there is our point, negative 2 plus I. And honestly, that's about all that you have to do for the complex number plane. at least for now. Again, if you do have artistic inclinations, I would encourage you to look up fractals, the Mandelbrot set, and kind of do some of your own learning in that area. All right, the last thing I'm just going to quickly mention, and we're not going to spend much time on it, is something about taking the absolute value of a complex number. So we know that an absolute value finds the distance from zero. And so if I'm asking you to find the absolute value of a complex number, what I'm asking you to do is find how far away it is from zero. So what does that mean in terms of the complex plane? Well, if we go back, and that's just the problem from before, 4 plus 3i, we know we went on over 4 and up 3 on the imaginary right here. And so the distance from 0 would simply be this distance right here. This would be whatever that number is. That's going to be 4 plus the absolute value of 4 plus 3i. So how do we calculate that? Well, if you'll notice, we have just made ourselves a very nice little right triangle where the real component is 4 and the height is 3. And so we are just going to do the Pythagorean theorem or the distance formula, and we're going to find the length of that hypotenuse. And so we know the answer to this question is going to be found by simply doing 4 squared plus 3 squared, which is 16 plus 9, which of course is 25. And we are looking for the square root of that. And so the answer is 5. So the absolute value, remember to write the question when you answer a question. The absolute value of that would be 5. All right, so go ahead and answer how far away this next one is. This time we've gone over 2 and up 1. And so we just have this right triangle with 2 and 1. So the distance, the absolute value of negative 2 plus I, is going to be 2 squared plus 1 squared, or 4 plus 1, or the square root of 5. So the absolute value of negative 2 plus I is the square root of 5. That's how far it away is from 0. Okay, that concludes our discussion on section 2.4 with the complex number plane. And what we're going to see in the next section is that the complex numbers are just kind of going to show up as some of our answers. Let me know if you have any questions, and we'll see you in class.